idea space, the final frontier. That is, how to depict ideas in a graphical language, not just in words or text. For example, consider these images of commonplace groceries. So what do all these items have in common? Are these? And how might one depict that graphically and not just using words? Or how to relate this item with that item? Or show the differences? Once again, graphically, and not just with words. As the old adage says, a picture is worth 1,000 words. For example, take the words, a cat with a striped tail. And this picture matches those words. But so does this one, as well as that one, and so on. Now, one can always just add more words, but that could just lead to excess wordiness as one tries to add those 1,000 words. Or alternatively, one could use fewer words and just leave it to the reader's imagination to fill in the details. But then that can often lead to miscommunication, where if there also had been the right graphics, the viewer might have gotten it totally right. And let this brief introduction act as a segue into the topic of this video, in fact, in this video series, UniML, where the Uni stands for universal, the M for modeling, and the L for language. UniML, Universal Modeling Language. Now, UniML, which typically might look like this, which can have a combination of text, graphics, and even images, should not be confused with XML, Extensible Markup Language, which has just formatted text, or Unified Modeling Language, UML, not UniML, which does have both text and graphics, though typically not imagery, but it has multiple types of diagrams, such as class diagrams, component diagrams, deployment diagrams, profile diagrams, sequence diagrams, communications diagrams, and bear with me, almost done, timing diagrams, and the ever-popular use case diagrams, and even more. In contrast, UniML typically only uses one type of graphic, but has a symbol set where one can model anything, hence the universal in UniML. Shown here, the rules for a card game. Here, modeling a string of Christmas lights. Here, modeling a tree in semantics. Here, modeling several sandwiches. Here, it models the difference between how UniML depicts relationships versus RDF, another way of constructing ontology models. Here, UniML is used to model the topological space of the power set of X equals A, B, C. Here, UniML is modeling aspects of itself. And so one can see that even though UniML can be used to model many different things, it does so using essentially just one format. So once one learns to read that format, one is good to go to apply that to any model. Thus, UniML can serve as a Rosetta Stone that could translate things from one model to another model via that common universal modeling language. And returning back to this graphic, one can see in addition to UniML, a modeling language, there is also Portals, a notional software-based tool. Notional in that that software has yet to be written, though, knock on wood, it may someday. Portals would enable a viewer to view various UniML models or a model builder to build them. And here are the properties in which Portals plus UniML is intended to meet. And yes, it may be just a bit pretentious on my part to think I can pull this off, but it's worth a try. And one can see more details on UniML on my Padlet virtual corkboard I made on it, A link will be in the description box. And the background music is from two of my improvs, which I have on yet another one of my Padlet virtual corkboards, and I'll give a link to that as well. And that's all, at least for this part one. Perhaps more to come.